Welcome everybody to chapter 3. Let's consider what we'll be covering in this chapter. So this is part 1 of part 2, of 2 parts of the time value of money. So part 1 really focuses on the financial fundamentals, introduction to some mathematical equations. We just want to become well-grounded. Particularly, we'll be discussing future value, present value, interest rates, and the number of periods. Now, specifically with this video, we're going to focus on chapter 3.1. So we're just going to focus on future values. When we're dealing with future values, we want to always visualize what that looks like in terms of a timeline. Okay, so when we discuss future values, we want to think of it as money moving forward. Okay, so our money is growing. So we start with our present value and the money moves forward in time, hence the arrow moving forward. So this is what we mean by our timeline. This is what we mean by our future value. Now, why are we solving future values? What is the purpose? Well, there's really 2 main opportunities here. First is determining the attractiveness of alternative investments. So we get to compare different investments and we can decide which has a higher future value or better future value. We're more likely to choose that investment. So very good for investment decisions. Second is it's helpful to understand costs that might be associated. For instance, the cost of inflation. How is that going to affect an asset in 10 or 5 years? Okay, so if we want to purchase a car or a house later down in the future, we want to know what it's going to cost us. So that's why we need to understand the future value. So let's consider 2 different scenarios. First is a single period scenario. This is also considered the lump sum scenario. And usually it's the most basic example. Let's consider the equation here. So we're really focusing on 2 things, which is first is the present value. And then we want to understand or figure out the interest of that present value. So how do we do that? Well, we take the interest rate of the present value, add them together, and that is how we determine the future value. Similar, just a little rearranged in terms of mathematically, but again, same idea. We have our present value, and then we want to figure out a certain percentage of that present value in terms of interest. That's going to help us calculate the future value. Let's consider John as an example here. So here we have a $200 initial investment. Okay, so $200 present value or principal. And we see that the interest rate on the account pays 6% per year. So again, we have present value, we have interest rate. We should be able to insert those variables and figure out our future value. So here we see, again, we start with that principal. And in this case here, we're basically taking 6% of $200, which is the $12, which is equal to our actual interest. And when we add them together, we get $212 value for our future value. Let's move on to the second example, which is the multiple period scenario. So in this case, we consider a multiple period if the money is left in an account for multiple periods, such as 2 years or more. So in this case, the future value of the sum of money will be equal to the original sum. Okay, so still have the principal, the present value, plus the interest over the multiple periods involved. Okay, so that's the interest that we discussed, but also we're also adding the interest earned on the interest as well. So there's a little bit more to consider. So when we look at the formula, similar to the single period, but now we have to account for the n, which is the number of periods. We can see that that's exponential. Okay, so that's going to help us kind of foreshadow the effect of compounding interest. And let's take a look at an example that does just that. It helps us recognize the value of compound interest. So in this case, John is actually now going to keep that money in for 3 years. Okay, so multiple periods. And we want to figure out how much money has been accumulated. We also want to figure out how much of that total sum is interest on interest. Okay, so we're going to actually break down the components of that total amount. And then we'll do the same thing, the same formula for after 10 years. And then maybe if we compare 3 to 10 years, we'll get an understanding of that compound value, okay? So here is the formula or the calculation for the future value after 3 years, right? So again, we're going to apply the formula given up above. We get a total amount, okay? So that's the total money accumulated, $238.20, okay? But how much of that is interest on interest, and how much of that is just interest paid for the 3 years? So again, if we start with the principal amount, okay? We multiply by the interest rate, and then we multiply by 3. So we can see that $36 is the interest amount, okay? So that's on the principal. But if we go ahead and break it really down, so again, we start with the total accumulated amount, $238.20, okay? So that's, we subtract the principal, which is the $200, and then now we subtract the $36, which is the interest on the principal. We can actually see that there's been an amount, which is, think of it as an additional amount, okay? And this is the compounding addition, which is the multiple period scenario. So there's been interest on interest of $2.20. And that's after 3 years. If we now compare to the 10-year scenario, okay, so same process applies, we can actually now start to see that that interest on interest is really increased now to $38.17. Okay, so good understanding of how we can see the effect of compounding interest and how we can actually deduct that from the principal and also the interest on the principal. So this is one way to calculate, obviously, which is using our formula. Okay, so we've discussed the formula method. Okay, and yes, it can be a little time-consuming and tedious, but the reason why we at least show it in our theory videos is so that you have a good understanding of where the numbers are coming from, have an understanding of the math behind it. Okay. Now, obviously, there's some more resources that we can use, and particularly when we're past the understanding, we want to do the calculations, there are some more options. So method 2 is the financial calculator approach. And what this means is if you have a financial calculator, there should be some sort of time value money keys that are associated with that calculator. We'll show you what those are in just a moment. I will say in my lab, there is a financial calculator available through the MyLab app or the program, so you can definitely use that. Okay, so that's one way to solve these equations. And another method is the spreadsheet method, right? So we can actually use Excel, and of course there's many formulas in Excel, and there's definitely a lot of time value money formulas that we can use also to calculate. So those are the 3 methods, and I will say the spreadsheet method is what we'll be focusing on, but you're always welcome to use whichever method you like. Now again, just some resources here for you to understand in terms of if you did use the financial calculator, this is the Texas Instrument variables that you can expect. So number of period refers to N, interest Y, which is our annual rate. It's always an annual rate. Present value, obviously PV, amount of payment, and future value. Again, similar variables available in the time value equations in Excel, and not to worry, there'll be lots of examples through your calculation videos, okay? But just a little introduction to these variables. So let's finish off by looking at one final example here, okay? Very similar to what we just saw. Again, we still have a principal or a present value. Here it's $5,000. The number of periods is 4 years, and we have a fixed interest rate of 5%. So we want to know what is really the future value, okay, or what will our account be valued after 4 years of this money sitting in that account. It's becoming reinvested after 4 years. Now, knowing our new methods, we can see again, we can use the formula method, of course, but if you did have your financial calculator, you can plug in those numbers. You will get the same value. Keep in mind you do have to plug in present value as a negative, and this is true for the financial calculator and the spreadsheet. Really, what that signifies is that the present value is a cash outflow. So that's why it's a negative, and you can expect a positive number in the future. Okay. So basically what that means is after 4 years, our account will be valued at $6,077.53. This concludes the theory for Objective 3.1. Join me next time as we discuss the present. Thanks for watching and happy financing.